Today we are going to construct a min-heap tree. Suppose these are the elements given. So now we are starting construct a min-heap tree. So first start with this. So first we write 10, then 75, then 45, then 26, then 55, then 5, then 24, then 31, then 90, then 80, then 15, then 64, then 21, then 7, then 8, then 120, and then 11. Now because we know in min-heap always parent will be less and parent having less value than the children. So from here we'll see how we can change it. So because 120 is greater than the parent, then it is okay, but 11 is less than the parent, so we will shift here. So 31 will come here and 11 will go there. Now we'll see here. So 11 is less and 21 is more. So this is more than parent, it is okay, but it is less than parent. So 11 will come here and 26 will come here. Now this part is over. Now we will see in this part 15, this is more than parent, it is okay, but this is less than parent. So what will happen? 55 will come here and 15 will go there. Now again here we will see here all okay because parent is less and childs are having more than parent value, so it is okay. But here we can see simply 7 is less while 24 is more. So what we will do, 24 will come here and 7 will go there, like that. Now we will compare this one. So from this one what we can see here, 11 is less than 75. So what will happen? 11 will go there and 75 will come here. 11 will go there and 75 will come here. Now further we'll see from here. So from here we can see simply this is more value and this is less value. So definitely what will happen, 45 will come here and 5 will go there. 45 will come here and 5 will go there. So now we'll see from here we will see. So what we'll see that this is 10 is more than 5. So what will happen, 5 will go there and 10 will come here. 10 will come here. Now next what will happen, this is okay, this is okay. Now again we will cross check that everything is okay or not. So from here we will cross check, this is 26, this is 31, this is okay. And here what we will see, here 75 is there while here 26. Here 75 at this note, but value here at this note is 26, so it's not possible. So what we will do, we will shift this value. So 26 will come here and 75 will go there. 26 will come here and 75 will go there. Now again we will cross check here. Again we will cross check because this is having less value and this is having more value. So parent is having more value than the child. That is not possible in min-heap. So what we will do, 75 will come here and 31 will go there. So we will write here 75 and here what will come, 31 will come. So now we'll see here 75, 120 and 31, that is okay, and 90 is also okay. Its parent is 26, which is having less value because all children are having 31 and 90. And here we can see simply what are the values. Parent is 11 and children are 26 and 15, that is also okay. And here this is 55, 80 and this is 15, that is also okay. Here it is 45 and this is 64, but this is 21. So what will happen? What we will do, we will shift this. So 21 will come here, and sorry, not this one, and 45 will come here, not this one. Here 21 will go there instead of 45, and 45 will come instead of 21. That is also okay. Now we will see here. Here 7 and here 8. So what will happen? That till now it is okay, but here we will see then till now it is okay. So this is 10 and this is 7, so it's not possible, because parent should be less, because it's min heap. So 7 will go there and 10 will come here. Now again we will cross check. So we'll see parent is more and child is less, so it's not possible in min heap. Then what we will do, we'll shift 8 here and 10 here. We'll shift 8 here and 10 there. Now we'll make this tree. Let's see what are the exact value of this tree. After that we'll again cross check. So first, what is this value? This root value is 5, so we'll write here 5. Then after that, what value we have? 11, so we'll write here 11. And what value we have at last one? 7, so we'll write here 7. Then after 11, what value is last at this note? 26, so we'll write here 26. Then what value is this note? 15, so we'll write here 15. Now what value at this at? 7. 7 is over. At this 21, so we'll write here 21. And this note, what value we have? 8, so we'll write here 8. And after that, at this note, what value we have at the end? 31, so we'll write here 31. And at this note, 90. At this note, what we have? 80. And this note, what we have? 55. At this note, what we have? 64. And this note, what we have? 45. And this note, what we have? 24. And this note, what we have? 10. And at this note we have 120. And this note, what we have? 75. Now we will cross check all the roots are less than the child or not. Here we can see simply, yes, this is less than child, and this is less than children. This is also 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 less than children, and this is also less than children. So now this is the correct min heap. So after so many modification, the correct min heap is this. So we have to cross check level by level. First we have to go this level, then 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 this level. And again we have to cross check that whatever changes we have made, these are correct or not, because in min heap parent should has less value than the children. So this is the way of constructing a min heap, by giving note.